Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will take a look at a homework problem from homework 8.1-8.2. This is problem number 1. We have a mayor who's interested in finding a 95% confidence interval for the mean number of pounds of trash per person per week that is generated in the city. So there was a study that included 189 residents whose mean number of pounds of trash per person per week was 36.9 pounds, and a standard deviation was 8.5 pounds. They want us to round our decimal places, 3 decimal places wherever possible. So first we note that we are given we're looking for 95% confidence, and we are given a sample of 189 residents, and then we have the mean to be 36.9 and a standard deviation to be 8.5. There is no mention of a population standard deviation, so no population STDEV. There's no sigma, and that would lead us to not want to use the Z distribution, even though we got 189, which seems to be a large number. But even then, we tend to go towards the T distribution for problems like this, where the population standard deviation is not given. All right, so now that we're using the T distribution, we're going to create this confidence interval. And in the confidence interval, we remember that we want to find out our error bound for the mean, which has a formula. In this case, since we're using the T distribution, we have the T critical value, T sub alpha over 2, and then we're going to multiply that by not sigma over n, but S, the sample standard deviation over n, over the square root of n. So this is our formula that we're going to use, and once we find this, we're going to say x bar plus and minus the error bound for the mean, and that would go on our left and right sides of the interval. Now there's a nice command in the TI-84, 83 calculator, but we're using Google Sheets, so let's go ahead and use Google Sheets. We have the information about the mean, the standard deviation, and the sample size. First thing we're interested in getting is the critical T value, and then we're going to say T sub alpha over 2. Now with a 95% confidence, alpha is 0.05, and half of that is 0.025. So maybe I'll put in a 0.025 here just to make it a little bit clearer. And the command for that is going to be an equal sign, and then it's going to be t.inv, the t inverse function, and then it's going to ask us for the probability. Now we can just put this 0.025 straight in there, and then our degrees of freedom would be 1 less the sample size, which is 189 minus 1, so 188. Now, if we take a look at the answer, I haven't pressed enter yet, but if you're hovering over here and taking a look at the answer, we get a negative number. Now, we want this to be positive, so there's a couple of options. The easiest option for me is to put a negative in front of that, so a negative and a negative would be a positive, because you want a positive value for your T sub alpha over 2. The other option for doing this is to take the complement of 1.25. Or 0.025, which is going to be the 0.975. That would be like the top half of your T distribution. So you could do either one of these. I would prefer to throw the negative sign because it's easier to remember. So I will change this to 0.025. And then I'll throw a negative sign in front, and then now it's a positive value. So when I press enter, I see a positive 1.97266. And I want to go with this particular value and just access this through the spreadsheet, so I don't have to round off and cure any errors by rounding off a little too soon before the final result. All right, so now our EBM, our error bound for the mean, is going to be equal to, so in the next cell I say equals, and then I will call on this first value, and I'll just click on that, and then times the time symbol. And I really don't need a parentheses for this, but I'm going to put it on anyways. And so open parentheses, and then my formula says I need the S, the sample standard deviation S. So I'll click on this 8.5, and then I will divide by the square root, SQRT, of n, and the n value is given here as well. And then I'll close the square root, and I'll close the other value, and I'll press enter. So this is my error bound for the mean. Okay, using the formula here off to the side. Now I want to subtract this EBM from the X bar, and I want to add this EBM to the X bar to get my lower and upper bounds. All right, so EBM, so X bar minus EBM. So this is a lower bound. I'll say lower limit, and I'll say equals to the sample mean minus the EBM, and I'll press enter, and then upper limit onto the next cell, say equals to, again, the mean. This time I'll hit plus, and then the EBM, and then I'll press enter. So it looks like our answer should be 35.6803 and 38.11966. So I guess we want to round off to 3 decimal places. You could do that kind of quickly by just highlighting and say we want to decrease the decimals to 3 decimal places if you want to do it that way, or 4 decimal places if you want to do it that way. So let's go with 3, and because that's what they're asking for, and so this is what we have. All right, 35.680 and 38.120. So let's get that down here for our results, our answer. 35.680 and 38.120. Okay, now before we move on, I wanted to show you another command here. In the step-by-step process using Google Sheets, you saw me try to find our T inverse and then our EBM, but let me and then get to the upper and lower limits. But let me show you another option. And for this, I want to introduce the command equals, and I think it's confidence.t. Okay, so let's take a look at that. So the first here in the cell, I put a little dash. Oops, let's clear this for a second. I put a little dash in front there so that it doesn't actually think it's a function. It's just showing me that I want to show the reader of this spreadsheet that I'm introducing a function, but I don't want to show the results. I just want to show the function command. So here I'll press equals without the little apostrophe, and so I'll start typing confidence, and I see a confidence T and a confidence norm. So if I press on confidence T, and then it's going to ask me for alpha. So alpha was 0.05 if you remember. The standard deviation was 8.5 if you remember, and then the sample size, not the degrees of freedom, but the actual size is this. So if I press enter here, you'll see that we get the exact same value as was computed from before. And so in this particular scenario, I kind of saved this extra step of finding the t critical value. No big deal. You can use this. It's a slight shortcut, and you still have to add and subtract from the mean, but I think that's just another option if you want. All right, the next part of the problem is just an interpretation. It says if many groups of 189 randomly selected members are studied, then a different confidence interval would produce from each group about what % of these confidence interval will contain the true population mean, and then about what % will not contain the true population mean. Well, it's all based on our critical or our confidence level that we're talking about. So to answer those questions, about 95% will contain the true population mean, and then about 5% will not contain the true population mean. All right, and I think that's it for this problem. There you have it. Good luck with the homework.